Samir is one of the co-founders of iRich, where he has developed system architecture for high-frequency trading. What made you so passionate about data science that you choose it as a career?
Data science is currently listed as one of the sexiest jobs of 21st century. The kind of results which we got using the data science, whether it's self-driving car or Google Translator making a revision on your behalf in a natural language, all of these things seems like magic. And thinking about the possibilities and the future potential of these things fills with you so much with energy that you generally want to be a data scientist.
As a data scientist, what is your day like?
So most of the data science works involves data cleaning, data management. So that is the first thing which we work on. Collect data, clean up data, make sense of the data. The second part is modeling. We primarily spend a lot of time on Jupyter notebooks, where we surf through a lot of frameworks. In my particular case, I work on TensorFlow. So we load models, we use some of the papers to create those models and tweak here and there. We play with a lot of parameters, a lot of features, and we tune a lot of it. And that I think is primarily what sums it up.
What, according to you, is the most important technical skill required for this kind of job?
The main thing which you need to work on while working as a data scientist is understanding the data and working with the models. A lot of the pain which has been there has been solved by recent frameworks, TensorFlow, PyTorch. These frameworks takes a lot of the pain out. I think the most important thing which I have found is if you can replicate the papers on your dataset or a given dataset and get the similar kind of results, you should be good to go to create future models.
What kind of mathematical knowledge is used by a data scientist on a regular basis?
So most of the mathematical knowledge required is generally abstracted out in form of framework functions. So most of these frameworks like TensorFlow, PyTorch, etc. gives you functions which abstracts out the low-level math. So we generally tend to think in terms of high-level constructs as sort of high-level models like CNNs, LSTMs, and things like that. All the low-lying underlying details and the mathematics required is generally abstracted out, either in terms of the model building itself or in terms of optimization as well.
Can you just explain that with an example?
So as an example, what is generally required is matrix algebra, vector multiplication, subtraction, and things like that. Bayesian probability, several mathematical small functions like exponential, tangential functions. How do they behave? What their curve looks like? Decomposition, derivatives. Understanding of derivatives is important, but those are actually pretty undergrad life kind of things.
Are all of these things that you mentioned, how much of it did you learn on the job?
So one nice aspect, or rather quirky aspect of data science is most of the implementations are not direct or straightforward. They're just tweaks which to get that implementation right. And that you cannot learn directly. That you have to learn on the job itself. The big data sets, what are the kind of small tweaks, very small tweaks, like probably rearranging the data itself in the reverse order, what the Google Neural Translation works have done. So small tweaks which gives you, which makes your implementation viable. Those are the kind of things which you learn on the job.
Why coding is so important for this role? Do you have any thoughts regarding the same?
So coding is definitely required. That's how we express our models. That's how we express our hypotheses in the form of the model actually. If we don't, then we have to rely on other tools and which cannot be that expressive. So once you are fiddling with a model and trying to get the results out, there will be so many variables which you need to tune and tweak. Once you understand it, your expression will be far more effective.
And from where one can learn coding skills exactly? If you could just elaborate that part as well.
So most of these frameworks are written in Python. So we should definitely pick a good book on Python, or at least a good course on Python. On the book side, I can think of Franco Collet's Deep Learning in Python. He is the author of Keras, one of the most popular frameworks in deep learning.
So my last would be, when you hire someone for the role of data scientist, what is that you look for in a person?
So apart from him being smart and can implement models, can implement papers and know Python skills, the important thing which I look is tenacity in the candidate, whether he can be going with the model for a long time and don't give up, because finding signals inside of such a noisy dataset, which financial dataset generally is very tough. And if you are not tenacious enough, you will certainly be very discouraged or disappointed in between, and it will take a long time before you get any fruitful result.